You may already know about the devastating power of tsunamis that are generated by earthquakes under the ocean. But what if I told you there was an even bigger rumble beneath the waves that can affect our planet in ways we never even see? In the dark depths of our oceans, a silent force is at work, creating ripples that extend far beyond the surface. This is the story of a megaquake, an underwater earthquake so powerful that its effects can change the shape of our planet. Join me as we explore the unseen forces that are constantly reshaping our world. Our journey begins deep within the Earth's core, where tectonic plates collide and diverge, shaping the very structure of our planet. When these massive slabs of rock grind against each other, they release tremendous amounts of energy, generating seismic waves that radiate outward. Most of these earthquakes occur along the boundaries of these plates, where one plate is pushed beneath the other, creating a subduction zone. The Pacific Northwest, Japan, and Indonesia are particularly prone to these megaquakes due to the convergence of several major plates. These areas are part of the infamous Pacific Ring of Fire, where over 75% of all earthquakes occur. One of the most notable examples of a megaquake occurred in 1960 along the southern coast of Chile. With a magnitude of 9.5 on the moment magnitude scale, it remains the largest earthquake ever recorded. The energy released by this colossal event was truly staggering, equivalent to the explosive power of approximately 50 billion tons of TNT. The quake triggered a massive tsunami that raced across the Pacific Ocean, leaving devastation in its wake. Its impact was felt as far away as Japan, the Philippines, and even the west coast of the United States. But the true extent of the Chilean earthquake's power goes far beyond the destruction it wrought. It also left an indelible mark on the very shape of our planet. The Chilean earthquake caused the land to uplift by several meters along a 750-kilometer fault line. This dramatic shift in the Earth's crust is not only a testament to the incredible force generated by the quake, but also provides us with a unique opportunity to observe the dynamic forces that shape our planet. By studying the land uplift, geologists and geophysicists gain insights into the behavior of the Earth's crust and the immense power of earthquakes. They can measure the deformation of the land, analyze the distribution of uplifted material, and investigate the mechanisms that cause the crust to buckle and fold. These studies help us understand the complex interactions between the different layers of the Earth's structure and provide valuable information about the strength and rigidity of the crust. Additionally, understanding the dynamics of land uplift is crucial for assessing the potential hazards associated with earthquakes. By analyzing the patterns of land deformation, scientists can develop better models to predict the behavior of the Earth's crust during seismic events. This knowledge is essential for developing effective strategies for mitigating the risks posed by earthquakes and protecting lives and property. However, the effects of a megaquake don't end at the water's edge. They can trigger landslides that reshape coastal landscapes, forever altering the interaction between land and sea. Imagine towering cliffs that suddenly collapse, releasing a torrent of rock and earth that rushes down to the water below. The force of a megaquake can be so powerful that it literally shakes the ground beneath our feet, causing entire sections of hillsides and mountains to crumble and slide. These landslides can bury coastal communities, alter river courses, and create new inlets and bays. For example, during the 2011 Tohoku earthquake in Japan, a series of powerful aftershocks triggered massive landslides that raced down the slopes of hills and mountains. These landslides added to the widespread destruction caused by the tsunami, burying entire neighborhoods and blocking roads and railways. The movement of the earth triggered by the earthquake caused some areas to rise while others sank, creating a complex and challenging landscape for rescue and recovery operations. The force of the earthquake and subsequent landslides also had a significant impact on the coastal ecosystem, altering the shape of beaches and coastlines and changing the habitat for local plants and animals. But the ripple effect of a megaquake doesn't stop there. These powerful events can also trigger volcanic eruptions, adding another layer of complexity and danger to the aftermath. As the Earth's crust shifts and deforms, it can put immense pressure on underground magma chambers, leading to the sudden release of volcanic ash and lava. Picture a chain reaction of natural disasters, where an earthquake sets off a landslide, which in turn triggers a volcanic eruption. The combination of these forces can lead to a catastrophic scenario, making the recovery process even more challenging. For instance, the 1883 Krakatoa volcanic eruption in Indonesia was triggered by a series of earthquakes and tsunamis. The initial earthquakes caused significant ground deformation, which created conditions that led to the massive volcanic eruption. The eruption resulted in the formation of a caldera and the displacement of over 36,000 people. The combination of seismic activity and volcanic activity poses a significant risk to human settlements and infrastructure. Coastal areas near active volcanoes are particularly vulnerable to the combined effects of earthquakes and volcanic eruptions. The Tohoku earthquake in Japan occurred in an area with several active volcanoes, including Mount Ibu. While the volcano did not erupt as a result of the earthquake, the strong ground motions caused by the quake did pose a risk of triggering a volcanic eruption. This highlights the interconnectedness of various natural phenomena and the potential for one event to trigger a cascade of others. In addition to these direct effects, megaquakes can also have far-reaching consequences for the global climate and environment. The sudden movement of Earth's crust can disrupt ocean currents, altering weather patterns and affecting temperatures around the world. Just think about the profound impact such changes can have on agriculture, weather patterns, and ecosystems. They can even affect the delicate balance of the Earth's climate system, reminding us of the interconnectedness of our planet's various systems. For example, the 2004 Indian Ocean earthquake and subsequent tsunami had far-reaching environmental consequences. The violent shaking of the Earth's crust triggered a massive tsunami that swept across the Indian Ocean, causing widespread devastation in coastal communities. The tsunami waves reached heights of up to 30 meters, inundating coastal areas and causing extensive damage to buildings and infrastructure. The force of the water caused significant erosion and altered the shape of coastlines, burying coastal forests and changing the course of rivers. This had long-lasting impacts on the local ecosystem, affecting habitats and species that relied on the stability of the coastline. But despite the destructive power of these events, life always finds a way to adapt and thrive. Even in the face of such challenges, nature's resilience is truly remarkable. Following a megaquake, there is often a period of recovery and rebuilding. Communities affected by the disaster work tirelessly to restore their homes, infrastructure, and livelihoods. As time passes, new buildings are constructed, roads are repaired, and the rhythm of life gradually returns to normal. However, the impact of the megaquake continues to be felt as the affected areas begin to recover. There is often a renewed sense of community and resilience among the residents. People come together to support each other, share stories, and honor the memories of those who were lost. Memorials and monuments are erected to pay tribute to the victims and commemorate the tragedy. Moreover, the aftermath of a megaquake often leads to advancements in science, technology, and disaster preparedness. Scientists work diligently to study the causes and effects of the earthquake in order to better understand and predict future events. They develop new technologies and instruments to monitor seismic activity and improve early warning systems. Governments and organizations implement stricter building codes and develop more effective disaster response plans. Education and public awareness campaigns are launched to ensure that people are prepared to take action in the event of an earthquake. As we continue to explore the effects of a megaquake, it's important to remember that every disaster also presents an opportunity for growth and change. After a megaquake, there may be a shift in priorities and a renewed focus on what truly matters. Communities may come together to rebuild in a more sustainable and resilient way, incorporating lessons learned from the disaster. Nature also has a remarkable ability to recover and adapt after a megaquake. While some species may be lost, others will find ways to survive and thrive in the changed environment. Ecosystems will evolve, and new species may even emerge, demonstrating the tenacity of life itself. So while megaquakes are undoubtedly powerful and destructive, they are also a reminder of the resilience and adaptability of both humans and nature. In the face of adversity, we have the ability to come together, innovate and rebuild. And even in the darkest moments, there is always hope for recovery and renewal. Now, if you want to go even deeper into the fascinating world of earthquakes, I've got something special for you. Check out this video where we dive into even more mind-blowing details about these powerful natural phenomena. See you there.